Right, so if we take a look at question 1, it says here, the diagram shows a cross-section of a solid prism. The length of the prism is 2 meters. The prism is made from metal. The density of the metal is 8 grams per centimeter cubed. Work out the mass of the prism. So the first thing that should come into your head is the formula for density, which is density equals mass over volume. Now before we start plugging in numbers, you have to see that we have centimeters and meters and centimeters cubed. So we're going to need to convert them all to the same unit. The easiest way will be to convert this meter into centimeters. So 2 meters in centimeters would be 200 centimeters. So we need to work out the mass. So if we get this formula here and rearrange, we need to get this by itself. So what's happening to mass right now? Well, it's being divided by volume, so we do the inverse. So if we times by volume each side, we end up with density times volume equals mass. Okay, so here is our formula set up. We can then start using this. So we know it's 8 grams per centimeter cubed, indicating that we do need to find the volume first. So volume would be length times width times height, or the cross-sectional area. And first find out the cross-sectional area. So what we can do is we can split this into shape 1 and shape 2. So the area of the cross-section would be for 1, it would be length times width, so therefore that would be area equals 7 times 2, so an area of 14 centimeters squared. For shape 2, well, if this here is 7 and we've got this 2 up here, that must mean that this section here is 5. Therefore we have area equals length times width, so area equals 5 times 2, so area equals 10 centimeters squared. So if we combine the two, we get 14 plus 10, so total area of 24 centimeters squared. So that's our cross-sectional area, which is all of this. We now need to go to depth of 200 centimeters, so therefore we take our cross-sectional area and times that by the depth, and that will give us our volume. So our volume will be 24 centimeters squared times 200 centimeters, which will give us 4,800 centimeters cubed. Okay, so now we have our volume. We can now use this formula. So we've got our density, which is 8 times by our volume, which is 4,800, and that will give us our mass. 8 times 4,800 gives us 38,400 for our mass. And if we're looking at the units, what would it be in? Well, we've got centimeter cubed here, and this is grams per centimeter cubed. So this would be 38,400 grams. Which we can leave it as that, or 38.4 kilograms. Okay, so on to question 2. Dylan is driving from London to Newcastle. he will drive a total of 240 miles. Then leaves London at 9:30. It takes him 1.5 hours to travel the first 90. Use this information to estimate the time it will take him to arrive in Newcastle. Okay, so we're looking at speed equals distance over time. So for the first 90 miles, we get given a time. So we've got 90 miles, the hour and a half at 90 miles. And from that, we can work out the speed. So for this first section, so if I just put a little 1 there, for the first section, that will be speed equals distance over time. So speed equals distance, which is 90 over time. So time here would be 1.5 to keep it in hours. Now you won't need to convert because we're looking for speed in miles per hour. You do not want to convert this into minutes, so you wouldn't want to do 90 over 90, so 90 minutes being an hour and a half, because that would give you a speed in miles per minute. So you want to keep this in miles, so this being miles, this being hour, and that divided on there means per miles per hour. Okay, there are certain situations where you do need to convert it into minutes or seconds, but not now. So that would be, which will give us 60 to 60 miles per hour. Okay, so let's just keep that in mind. Right, so it says so from this he's going 60 miles per hour. He leaves London at 9:30. How long will it take for him to travel to Newcastle? So if we know from what we've just worked out, speed is 60 miles per hour, then we have we don't have the time, we have the distance. So we have distance to London to Newcastle is 240 miles. We're basically being asked how long will it take. So writing the equation again, speed equals distance over time. We need to rearrange this, so we need to get the equation to time equals. Okay, so this is distance divided by time, so we need to times both sides by time. Then we have speed times time equals distance, and then time is being times by speed, so to get rid of that we need to do the inverse, which is divide by speed, and therefore we have our final equation, which is time equals distance over speed. Okay, so from that we can do, I'll write that just here, time equals, we got a distance of 240, and I'll just put miles there, 240 divided by 60, and that will give us a time of 4 hours. Okay, so if we got 4 hours, if he leaves at 9:30, we need to add 4 hours onto that, which will give us a time of 1:30. So either 1:30 PM or 13:30. So B, write down one assumption you made in your answer to part A. Okay, if your assumption is wrong, how would this affect your answer? So what assumption did we make? Well, they gave us the first section where it said it took him an hour and a half to travel the first 90 miles. So by this part here, we assumed that he kept driving at 60 miles per hour. So kept driving at 60 miles per hour. So for the entire journey. If your assumption is wrong, how would this affect your answer? Well, it would be assuming that there was no stops or he didn't speed up. So you could say that if he stopped, arrived later, you could say due to slower speed, arrive earlier if he drove at 70 miles per hour, for example. Okay, so question 3. There are 18 packets of sweets and 12 boxes of sweets in a carton. The mean number of sweets in all the 30 packets and boxes is 14. The mean number of sweets in 18 packets is 10. Work out the mean number of sweets in the boxes. So what we need to do here is the first thing is write the formula. So the formula for mean is the mean equals sum of data over the number of data inputs. So number of data inputs. Okay, so the first part here says the mean number of sweets in all 30 packets and boxes is 14. So if I write here packets and boxes, we then have mean equals sum of data over the data inputs, so the number of data inputs. And if we fill this in, so it says the mean is 14. So instead of writing the mean, I'm going to write 14. So 14 equals the sum of data. Now we don't have that, so it remains a sum of data over, and they told us that there are 30 packets. Okay. So in order to work out the sum of data, so the total amount, we need to do some rearranging. So sum of data is currently being divided here by 30, so we need to do the opposite, which is times by 30. So times by 30 times by 30, so we get 14 times 30 equals sum of data. Doing it quickly on a calculator just to speed things up gives us 420 equals sum of data. Okay, so let's just key that there for now. Okay, so second part says the mean number of sweets in 18 packets is 10. So now, instead of packets and boxes, we're just looking at packets. So again, the same thing. We write mean equals sum of data over data inputs. And then fill in what has been given. So the mean number of sweets in 18 packets is 10. So therefore this will be 10. So 10 equals, again we don't have the sum of data, but we do have the number of inputs because there's 18 packets. So over 18. Again doing some rearranging. We times by 18 here and times by 18 here. So then we get 10 times 18 equals sum of data. Therefore we get 180 equals sum of data. So this is for us to know too. Okay, so we've got, if we're looking here, we've got packets and boxes, and we've got packets. Okay, now the actual question itself says work out the mean number of sweets in the boxes. So we need to find boxes. Okay, so again, if I write that formula, mean equals sum of data over the data inputs. Okay, so that's just the number of values. Right, so the mean would be, mean equals, we've got the sum of data. So here we've got packets and boxes add up to 420, and just packets alone give 180. So the difference must be the value of the boxes. So we need to do 420 take away 180 over the number of data inputs. So how many boxes do we have? We have 12 boxes, so this would be over 12. So therefore we'd write it again, mean equals 420 take away 180, which is 240 over 12. So therefore our mean would be 20. Okay, question 4. Find the value of n so that 2 to the 6 times 2 to the 3 divided by 2 to the n gives you 2 to the 5. So you're going to need to know your indices here and a few of the rules. So we have 2 to the 6 times 2 to the 3 all over 2 to the n. Yeah, and that should equal 2 to the 5. So if we have a look at the top, the numerator section for now, we have 2 to the 6 times 2 to the 3. So if you remember from indices, we add when we're multiplying. So that gives us 2 to the 9 divided by 2 to the something, and that gives us 2 to the 5. So basically what we need to do is we need to find out what this number here is. So if you remember from indices, when you're dividing, you're subtracting these indices. So basically what number take away from 9 will give you an answer of 5? Well, that is 4. So 2 to the 9 take away 2 to the 4 gives you an answer of 2 to the 5. So therefore n equals 4. Okay. Right, okay, so question 5 says enlarge triangle T by a scale factor half, center 2, 0. So scale factor of half would mean that it's going to decrease in size, and that's because anything less than 1 would be a decrease. Anything greater than 1 would be an increase in size. Okay, so we've got a center point that we need to mark down, which is 2, 0. So that would be this point right here. Now there are several ways to do this. You can use a ruler to do this, but what I'm going to do is the coordinate method. So we've got a center point 2, 0. So what I'm going to do is count the coordinate position from the center point. So for example, I'm going to find out what this coordinate here is. So that would be 2 across. So if I draw that 2 across, and 1, 2, 3, 4 up. So from that center point position, this point here is going to become 2, 4. Okay, and I'm going to do the same for the other vertices. So this point here would be 1, 2, 3, 4, 4 right and 4 up. So 4 right and 4 up. And the last vertex up here will be 2 across and 8. So 2, 8. Yes. 2, 8. Now, because I've measured from that center point, I need to apply the scale factor. In this case, it's half. So what I'm going to do is times all of these coordinates by half. I'm going to write the new coordinates just underneath them. So if I times 2 by half, I would get 1. And if I times 8 by half, I would get 4. So remember, timesing by half is the same as dividing by 2. I'm then going to do that for the other vertices. So I've got 4, 4 here. So timesing those by half, I would get 2, 2. And for this last vertex, I'd get 1, 2. Now with my new positions, I'm then going to plot that from this center point. Okay, again. So now let's do that in black. So this part here needs to now move to 1, 2. So 1 away from the center point and 2 up. So that's here. This vertex here now needs to move 2, 2. So 1 across, 2 across, 2 up. So that would be here. Okay, and this one up here is 1, 4. So 1 away from 2, 0, and 4 up. If I connect that up now, there's my new triangle position. Okay, question 6. There are 20 counters in the bag. 8 of the counters are yellow and 12 of the counters are green. The thief takes at random 2 of the counters. Work out the probability that 2 of the counters are different colours. So we're going to start off with our probability tree because it's going to be 2 events. Okay, so if I start here, I've got yellow and then green. Okay, so if I go for the yellow route, there's a total of 20 counters. If I go for the yellow route, this will be an 8 out of 20 chance. If I go for the green route, it will be a 12 out of 20. So this, if you like, here is my first selection. Okay, then I've got a second selection after this point. So it will be again this. Here will be my yellow choice, and here will be my green. Here will be my yellow, and here will be my green. Okay, so this is the part that you really need to consider. This is my second choice. So if we imagine starting through here and following like a path, okay, at this point here, 1 has been taken. So in this case, if I follow this path, a yellow has been taken. So that means that the counters now, there is now 1 less. So this fraction would become 7 out of 19. Okay, it was 8, but if I've just chosen a yellow, it's now become 7. So 7 out of 19. If I've gone this route, I've selected a yellow, not a green. So the green will stay as 12, but this will also become out of 19. Okay, so basically what's happened is the green has now got a higher chance of being chosen because they're now because 1 yellow has been chosen. So let me just get rid of that path. So this will be 12 out of 19. Okay, now if I go for this bottom section here where the green has been chosen, the yellow will stay at 8, but it will also go to 8 over 19. But because through this path the green has been chosen, this goes to 11 out of 19. So I end up with my choices here of yellow, 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 green, green, yellow, and green, green. The most important thing to remember is the pathways. So let me just show you this again. So let's say we start here. You go for a yellow and a yellow. Okay. You start here. You choose a yellow and then a green. You start here and you go for a green and then a yellow. And you start here and you go for a green, then a green. So there are 4 different pathways that you can choose. Now the question asks, work out the probability that the 2 counters are different. So that would be YG and GY. Okay, because GG, green and green, that would be the same. YY, yellow, yellow, that would be the same. Probability trees, you need to remember that going across is times, going down is add. Okay, now if you think about this from a fraction point of view, if you times fractions together, the value will get smaller. So therefore, choosing things in a certain row, less chance of it happening. Okay, so that's why you, as you go across, you times. So if we go for YG, we'll have 8 over 20 times 12 over 19. And for green yellow, we'll have 12 over 20 times 8 over 19. So if we work out what that is, I'm going to use a calculator just to speed things up. So we get 96 over 380. Okay, so we've got our two probabilities. Now we need to go down and add them. So 96 plus 96 will give us 192 over 380. Okay, question 7. N is an integer greater than 1. Use algebra to show that n squared minus 1 plus n minus 1 squared is always equal to an even number. So n is an integer greater than 1. Right, so if we have n squared minus 1 plus n minus 1 all squared, so always equal to an even number. Now an even number would need to have a factor of 2. So let's just try this out. So let's just keep this in mind for now. So let's expand this out. So we've got n squared minus 1 plus n minus 1 all squared would be 2 sets of brackets of n minus 1. Now if I have n squared minus 1 plus, from here, if I remember FOIL, you can write out like this if you'd like, or do it quicker. For the first of each term would be these two. So n times n would give n squared. The outside terms would be n times minus 1, which would give us minus n, or minus 1n, or minus n. Then we have the inside, which is minus 1 times n, which again would give us minus n, or minus 1n. And the last, which would be minus 1 times minus 1, which would give us plus 1. Remembering that 2 minuses when times will give us a positive sign. So if we write all of this here to the left, we end up with n squared minus n plus 1. So simplifying this, we end up with n squared minus 2 lots of n plus 1. Now at this point, we can collect some like terms. So I'll just underline some like terms for now. Okay, so looking at this, we've got n squared plus n squared, so we get 2n squared. We then have minus 1 plus 1, or minus 1 plus 1 will give us 0. Therefore, all we have left is minus 2n. Now at this point here, remember at the beginning I mentioned that for it to be an even number, it has to be a factor of 2. You can see here that there looks to be like a factor of 2. So what we can do is we can factor this out. So don't forget, factoring means to pull out the highest common factor, or to put it into brackets. So we could put 2 here and 1n, open that bracket up, and then make this n minus 1. So this is what we end up with so far. So let's see if this actually makes sense. N is an integer greater than 1. So if it's greater than 1, then we could use n equals, let's say, 5. Okay. So it says here, use algebra to show that this is always equal to an even number. So let's have a look. If we put n as 5, because it just says any number greater than 1, so say put n as 5, let's try this. So we've got 2, open bracket 5, open bracket 5 minus 1. So if we do 2 times 5, that will give us 10. Open bracket 5 minus 1 will give us 4. And then 10 times 4 will give us 40. Well, that's given us an even number, hasn't it? Let's try n equals 3. Okay, so then we've got 2n minus 1, then we've got 2, bracket 3, 3 minus 1, close bracket. Then we have 6, 2, which gives us 12. Okay, so you can check this one more time. Let's say with 10. It's a good idea to, once you've done the algebra, to actually check this. So number greater than 1, and go for several values to show that you're trying to show on top of the algebra, you're actually trying numbers in to see if it makes sense as well. It's a good way to check that the algebra you've done is correct. Okay, because remember, when it says show that, generally it means that that is the case, and you just need to prove it. Okay, so don't be tempted to say it is not the case and you don't get an even number. So back to this, so we've got 2, open bracket 10, 10 minus 1, which gives us 20, open bracket 9, because 10 take away 1 is 9, and that 2 times 9 is 18, and there's a 0, so 180. So again, all of these numbers here are even. Okay, question 8. ABC is an equilateral triangle, D lies on BC, AD is perpendicular to BC. Prove that triangle ADC is congruent to ADB. Okay, so we can say that we know it's an equilateral, so this side will equal this side, which will equal this side. We also know that this angle here will equal this angle here, will equal this angle up here. So there are several ways we can do this. So if I write statement and reason, first method I'm going to say is that AB, so AB on the left there, equals AC. Okay, and then say given, and then in brackets equilateral triangle. Okay, then I will say that AD equals AD, the center. I'll say that that's shared, or you can say common. It's going to be common in both triangles. And then I can say that ADB, angle ADB, equals angle ADC. And that is given initially. Then you can put 90-degree angle. So if I look at these three here, I've said that this side is the same as this side. Okay, so I've got the side. I've then said that AD equals AD. So they share this centerpiece. So that's again another side. And last, I've got this angle here is shared with this angle here. So if I have a look at that, that's an angle. Okay, now be very careful because this does look like arse, which does not prove congruency. But if you have a look, we have the right angle, which is this one. So right angle. We have AD equals AD, which is the side. And the AB equals AC, they are in fact the hypotenuse. So for our congruency proof here, we actually have our HS. Alternatively, if I just get rid of this, we can prove it in another way. So let me write over on the left hand side now, statement, let me just put number 2 and reason, because it really depends on how you look at these questions. So again, let me just mark on the triangle, equilateral, 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 angle, angle, angle. Okay, so on the left there we did RHS. Let's look at another way of doing this. So we could say that AD equals AD, and then shared, and that's really given. Okay, so that's this centerpiece. Then we could say that angle ABD, so that's this one right here, okay, which is 60 degrees, equals this one here. So that would be ABD equals ACD. That would be for equilateral triangle property. And that would be from an equilateral triangle property. So let's put 60 degrees there. So we've got side, angle. What else could we do? We could then say that AB equals AC, and that would be another equilateral property. Okay, and if you look here, that would be side, angle, side. Okay, so there's just two ways of doing it. There are a few other ways too. Okay, so if we know that from above the two triangles are congruent, that would mean that BD equals DC. Okay, and that's from the congruency we just proven above. So if they are both congruent, that would mean that BC, so the entire bottom of the triangle, would be equal to AB. So if the entire bottom would be equal to the entire length of AB, that must mean that the length of BD is half of AB. So our main proof was up in question A, and what we need to do here is finalize it. So let me just run through this again. We've said, and I'll try and highlight the area. So we've said that BD, so this length here is, I'll try and highlight here, so BD is the equal to DC. And we proved that from the congruency above. Remember, it means they can fit on top of each other, congruency. So BD equals DC. Now, if those two equal each other, that must mean that the entire length here of BC, okay, here, entire length of BC is equal to AB, okay, which is here. And if that is true, that would mean that BD, so BD here, is 1/2, so half of the length of AB. Okay, so rationalize the denominator basically means get rid of the surd is in the bottom. So we have 6 over root 5. To get rid of that, we times by root 5 on both the numerator and denominator. So we end up with 6 root 5 over root 5 times root 5 will give root 25, and this would then simplify to 6 root 5 over, what's the square root of 25? 5. So end up with 6 root 5 over 5 as your answer here. Expand and simplify 2 plus root 10, root 5 plus root of 20. So we need to use the FOIL technique. So we can do FOIL here. Okay, so first terms, 2 times root 5 would be 2 root 5. Outside of each term would be this one and this one, so that would be 2 root 20. The inside would be root 10 times root 5, so that would be root 50. And the last would be root 10 times root 20, which would be root 200. We then put all of this together, so we have 2 root 5 plus 2 root 20 plus root of 50 plus root 200. Now, in order to be able to simplify, we need them to be all like terms, which means that we have to do some simplifying. So, for this first one here, I'm going to see if I can get that to a root 5. So, if I have my root 20 here, I can then split that into root 5 times root 4. Well, we know that the answer to root 4 is 2. The square root of 4 is 2. Okay, so that would simplify down to, let me just write this here, so this would be 2 root 5 plus, I've still got the 2 here, and I dragged up the root 20, so in red I'm going to write the answer to this, so this would be 2 root 5 now, so this would be times 2 root 5. Okay, and then for the plus root 50, I just get rid of this FOIL section to make some space. The root 50, I can split into this tree, so I can have root 10, root 5, root 2 times root 5. Okay, so I can't simplify that down any further, so I end up with plus root 2 times root 5 times root 5 plus square root of 200. So let me do that over here. Root 200, root 2, root 100, root 2, root 50, root 2, root 25. Okay, so if I just write this here quickly, I end up with root 2 times root 2 times root 2 times root 25. I can simplify that here actually. So root 2 times root 2 times root 2. Well, no, root 2 times root 2 is root 4. So it'd be root 4 times root 2 times root 25. This would give me square root of 4 is 2 times root 2 times square root of 25 is 5. So I can just write this slightly simplified version up here too. Now if I have a look at this, I need to see if I can simplify now. So I've got 2 root 5, so let me keep it as that, plus 2 times 2 root 5, so I'll then do 4 root 5 plus, I've then got root 2 times root 5 times root 5, well that can become root 2, and that would be root 5 times root 5, which could be root 25, and the square root of 25 is 5. Okay, so I've just simplified that down there. Then I've got plus 2 times root 2 times 5, so I can do the 2 times the 5, which will give me 10 root 2. Okay, so now if I have a look at what I've got 2 root 5 plus 4 root 5. Okay, so in terms of root 5s, I've only got those. So I've got 2 lots of root 5 plus 4 lots of root 5. That will give me 6 lots of root 5. Plus, now I've got root 2 times 5. plus 10 root 2. So I've got 5 lots of root 2. So really, to make it a bit easier to see, I can, right, this is 5 lots of root 2. Then you can see I've got 5 lots of root 2 plus 10 lots of root 2, and that would give me 15 lots of root 2, and that would be my simplified answer. So it's quite a bit of working out for that one there. You can use factor trees, as I've done here, to try and simplify it. What you'll notice is the more experience you'll get, you'll be able to see like root 25 and you'll know that's 5, and you won't need to carry on going down the factor tree. But what you can do is you can continue going all the way instead of trying to get a shortcut, and it would just mean that you've got a lot more work. But if doing that method gets you the correct answer, then you're better off doing that. Then as you get better at it, you can then start looking for some shortcuts. Okay, in question 10, P is inversely proportional to V. When V equals 8, P equals 5. Find the formula for P in terms of V. So we know that we have P is inversely proportional to V. So we've got P, and then we'd have 1 over V because it's inversely proportional. So we then remove the proportion sign and we replace it with an equals and a K, and then it will be K times 1 over V. Okay, now an easier way to write that would be P equals K over V. So basically we need to write this formula as we have it now, but we do need to find out what K is. So we need to write the actual final formula. So we're giving V and P, so we can work that out. So to find out what K is, we firstly need to rearrange for it. So K is being divided by V. So in order to get rid of that, we need to multiply by V on both sides. So then we end up having P times V equals K. We are given the values of V and P. So we have 5 times 8 equals K, and you can put that in brackets. Okay, just to make sure. And 5 times 8 would be 40. So therefore K is equal to 40. So if we now write our final formula, we will have P equals 40 over V, and that would be our final answer. Now for part B, it says calculate the value of P when V equals 2. So this is where this formula comes in. So we write that again, P equals 40 over V. We need to find out the value of P. As soon as we have P equals, means we do not have to do any rearranging. So therefore it's just P equals 40, which is in the formula, over V. V is 2, so P equals 40 over 2. Therefore P is equal to 20.